The ninth chapter in IB chemistry will be oxidation and reduction. Here you need to first define what is oxidation and what is reduction in terms of electrons, oxygen, hydrogen, and oxidation number. Okay. You also need to be able to, or rather, teach your student how to calculate oxidation number. Oxidation number of elements. Okay, then they also need to determine which species get oxidized or reduced in reaction. Okay, so usually they will have to calculate the number of the oxidation number before and after the reaction, and if there is an increase, they can decide there is an that element or that species is oxidized. If not, then it is reduced. Okay, and in redox equation, your kids need to be able to learn. The kids need to be able to balance redox equations. Okay, there are two methods that you need to teach them. One is the half equation method, and the second one will be the oxidation number methods. Okay, this one will be discussed more in the question section of the video. So here, the kids needs to be able to identify oxidizing and reducing agents. Okay, so they need to know that if a species get oxidized, it is a reducing agent, and if species get reduced, it is an oxidizing agent. Okay. In reactivity, they should know from previous levels of education like O-level or IGCSE about the reactivity series. So in the reactivity series, you need to teach your student how to determine which one is the strongest reducing or oxidizing agent in the series. Okay, so strongest and weakest. What do I mean by this? For example, your students need to know the list like potassium, sodium, and so on until gold, which is the most unreactive element in the list. Okay, so you need to explain that potassium can become potassium ion and gold can become gold ion. And how? Because potassium has the greatest tendency to be oxidized, potassium is the strongest reducing agent. Okay? And because potassium has the greatest tendency to be oxidized, potassium ion will have the least tendency to get reduced. Therefore, this will be your weakest oxidizing agent. Okay, so one of the more important thing to emphasize here is that potassium and potassium ion are different. Potassium cannot act as an oxidizing agent, and potassium ion cannot act as a reducing agent. Most students will use them interchangeably. Like for example, if they ask when they ask what is the weakest oxidizing agent, then they'll say it's potassium, but actually it's potassium ion. So just be sure that you emphasize that to your student. So based on, once they know the reactivity series also, they need to know the feasibility of a reaction happening. Okay? So this is where you tell them a more reactive element will displace the ion of the less reactive element in a compound. Okay, so for example, if you put potassium inside a solution of gold nitrate, for example, the gold will be displaced from the solution and potassium will dissolve. So the same thing, you need to apply this to the halogens also, but in the same concept. The next part of redox, we are going to be discussing about voltaic cell and electrolytic cell. Mainly, students need to know the similarities and differences. Okay, so that includes the setup. For example, a voltaic cell will usually involve two different beakers or containers attached to a voltmeter, and there is a salt bridge. Okay, and in electrolytic cell, you have also two electrodes, but it will be connected to a battery instead of a voltmeter, and usually it's contained in one beaker. You need to know, your students need to be able to identify which one is the positive electrode or negative electrode in each. They need to be able to decide which one is the anode and which one is the cathode. Okay, they need to know where oxidation or reduction will happen. For example, something like, okay, oxidation will happen in this cell because of what. So they need to know how to do that. Yeah. Then for the standard level, these are what they need to know, and on top of that, they need to know how to determine the product at each electrode, products formed at each electrode. Okay, if electrolyte is molten salt. Okay, so for standard level, they only need to know the products when the electrolyte is a molten salt. But if it's higher level, they also need to know if the electrolyte is an aqueous solution. Okay. For standard level, these are the only things they need to know about the voltaic cell. Okay, but for higher level, they need to learn about standard hydrogen electrode, so they need to be able to draw the standard hydrogen electrode. They need to know the standard electrode potential. Okay, they need to know about the Inert cell of a voltaic cell, how to calculate this out. They need to know the spontaneity of reaction based on the Inert cell calculated. And for higher level also, electrolytic cell, they need to learn about electroplating. Okay, so usually for this, when I'm teaching a voltaic cell and electrolytic cell, I don't follow the flow given in the notes. I'll just compare them side by side immediately.